Hey guys, welcome to the Raptors, a digital platform of the RAPT Excellent Tutorials. Today we are going to discuss set of important questions from maths, which may turn up in exam tomorrow. The CBSE board exam is scheduled for 9th of April. So I have handpicked few very important questions which may come directly in your exam tomorrow. Not only that, a question similar to what I'll discuss here may also turn up. So stay tuned, guys. We'll start with all the important questions. So we come to a relation and function question. You see, the question is a relation R is defined on n cross n. This is extremely important to pay attention at. It is from natural number to natural number. Now it is defined as AB related to CD, like A by C is equal to B by D. So this is the relation when AB is related to CD. We need to prove or show that this relation is an equivalence relation. So what we are going to do, we'll prove it as reflexive, symmetric as well as transitive. And if we can prove it, then it will be an equivalence relation. So the first thing we are going to prove is reflexivity. So reflexive. So in reflexive, same element is related to the same element, right? So in reflexivity, AB, R, AB must belong to the R, should be there in R, right? And we will verify whether this is there in R or not by using this relation. Now you see A by C, that means first element of the first ordered pair is related to the first element of the second ordered pair. So A by A, that means A by A must equal to B by B, right? Second element divided by the second element of the second ordered pair. So if you solve it, is 1 equal to 1, which is true. Like 1 is equal to 1, right? So it is true. Therefore, AB comma AB belongs to R. It's there in your relation. Therefore, R is reflexive, right? Now we go to symmetric. Now symmetricity says if AB, R, CD belongs to R, then CD, R, AB should also belong to R, right? Like you think in terms of simple relation, if A comma B belongs to R, then B comma A should also belong to R. Now here, this ordered pair, you should treat this ordered pair as single element. So AB and CD belongs to R. Therefore, you should flip it. CD and AB should also belong to R, right? Now we'll check if AB, CD is related, then what we get. If AB, since AB, R, CD belongs to R, this implies that A by C must equal to B by D, right? As per relation, A, B, C, D, and A by C equal to B by D. Now, if this has to be there, if this is true, then this should give first by first, C by A must equal to D by B. Now you just flip it. If you flip it, A by C must equal to B by D, which is true, which is already given, right? So we can say hence R is symmetric. Now we come to transitive. In transitive, we assume that two relations are true. We need to prove the third relation. So we assume that first is related to second, second is related to third. We need to prove that first is also related to third. That is transitivity, right? So we assume that AB, R, CD is already in R. That means A by C is equal to B by D. We also assume that CD, R, EF, we choose another ordered pair, A, B, C, D, EF also belongs to R. That means what will be the relation? C by E must equal to D by F. we need to prove that AB or EF also belongs to R. So what should be the relation for this? A by E must equal to B by F, right? Now we have these two relations. Let's say this is 1 and this is 2. No, let me write this as 1, this is 2, this is 3, this is 4. Now you see, from equation 3 and 4 we want to derive this relation. So you see, if you multiply 3 and 4, multiply equation 3 and 4. So what we are going to do, what we are going to get, d by d into d by f. So you see, c gets cancelled, d gets cancelled, what we get? A by E equal to b by f, which is true, right? Since these two relations are already there, we need to prove this transitive, the third relation. We get this third relation from the given two relation. That means this is true. Therefore, from 5 and 6, R is transitive. So what we prove? We proved that the R is reflexive, R is symmetric, and R is also transitive. Therefore, we can say from equation 1, 2 and 7, R is an equivalence relation. And then you need to write showed, because the question asks to show you, right? So that's how you solve such problems. It is highly likely that this type of problem will turn up. So this question from functions asks us to check whether a function which is defined from, which is mapped from real number to a closed interval of minus 1 by 2 and 1 by 2, and the function is defined as x by 1 plus x square, and we have to check whether the function is 1 1 and onto or not. The question is 1 1 and onto or not? That we need to check. So we'll check 1 1 first. 1 1 means injectivity. So we'll check injectivity first. We know for injectivity the condition is if f of x1 is equal to f of x2, this implies that x1 equal to x2. If this condition is satisfied, the function is 1 1. Now our will impose this condition and we'll see whether we are getting x1 equal to x2 or not. So f of x1 equal to f of x2 will give us x1 1 plus x1 square equal to x2 by 1 plus x2 square. Now we cross multiply. After cross multiplication we get x1 plus x1 x2 whole square, x2 plus x1 square x2. Straightforward. Now what we are going to do, we'll bring x2 on left hand side, x and this term on the right hand side. So if you bring x1 on the left hand side, we get x1 minus x2, and on right hand side we may take x1 x2 common, so we'll get x1 minus x2, right? See, if you take these two terms on the right hand side, you will have x1 square x2 minus x1 x2 square. So you can take x1 x2 common, right? From x1 square will be left with x1, and here you have x2 square, so x2 minus, like x2 will be left. Now we take the whole term on the left hand side, we also have x1 minus x2 here, so we can take x1 minus x2 common, right? So what we're going to have, x1 minus x2 will be taken common, and then we'll have x1 x2 which is equal to 0. Now we see the product of two terms are 0, right? So if product of two terms is 0, either the first term is 0 or the second term is 0, or both of them are 0. So we'll impose this condition. We'll have x1 minus x2 equal to 0, or 1 equal to 1 minus x1 x2 equal to 0. So this implies that x1 is equal to x2. So we'll take this condition. So the first condition gives you x1 equal to x2, and then second condition gives you 1 equal to x1 x2. That means x1 equal to 1 by x2. So what do you see? We are getting x1 equal to x2, but we are also getting x1 equal to 1 by x2. That is inverse, first term is inverse of the second. So it is not 1, 1. Hence, fx is not 1, 1. Because we are getting two conditions, right? Two conditions are true. Now we come to onto part, onto a surjectivity part. So for surjectivity condition is that for every y there should be some x. So we know for all values of x belonging to x, no, for all values of y belonging to y there exists x belonging to x. So we'll impose this condition, that means fx is given as x by 1 plus x square. So y is equal to, right? Now we'll cross multiply, we'll have y x square equal to x. We'll make it a quadratic equation, y x square minus x plus y equal to 0. So this is quadratic equation in x. How to solve quadratic equation in x? X will be minus b plus minus square root of b square minus 4ac by 2a. Now x will be 1 plus minus square root of 1 minus 4 y square divided by 2y. Now you see, here x is being mapped from real number to minus 1 to 1. So x should be real. If x is real, the value in this square root should be positive. If the value in the square root becomes negative, this will give you an imaginary number, complex number. So you want this value to be always positive. Otherwise, it will give you a imaginary number. And your mapping is from real to a range minus 1 to 1 by 2. So for x to be real, 1 minus y is 4y square should be greater than equal to 0, should always be positive. That means y square should be less than equal to 1 by 4. Right? You shift y square on the right hand side, so 4y square should be less than 1. That means y square should be less than 1 by 4. So this will give you y should belong to minus 1 by 2 to 1 by 2. Which is exactly the range that is given. So all the range values have some real values of x, because we imposed condition for real x and we are getting this range. So all of these are getting mapped to, they have their pre-images in real number. So all the codomain elements are getting mapped. That means this is onto function, right? Hence fx is onto. Therefore function is 1 1 and function is onto but not 1 1. Okay, onto but not 1 1. All right, so this may be this is very extremely important question. Now you see, I'll slightly change this question. I'll slightly change the nature of this question. If instead of this the function mapping is from R to R, in that case what will happen? All right, so you see function mapping is from R to R. So x is also real, y is also real. Now you see, for 1 1 part there is no change, right? It won't be 1 1 because you are getting two conditions. Now the change is for onto. In onto, x will be real only when r is this, only when y is this, right? If you choose any other value from like any other value from this range, like not from this range, you choose some other value of y, you get imaginary x. For example, if you choose y to be 1, so if you choose y to be 1, then this will be 1 minus 4 minus 3i, which is imaginary. So if y is real, let us see the mapping x, y. Your x and y, x is minus infinity, 0, 1, 2, plus infinity, and y is minus infinity, 0, let it be minus 1 by 2, 0, 1 by 2, plus infinity. So x is real only for values of y between minus 1 by 2 to 1 by 2, right? If you choose 1 or something, x becomes imaginary. So the mapping is like that. Everything is mapped in this region only, because real values of x are mapped for minus half and half. That means other values like minus 1, minus 2 are not being mapped for real. If you choose minus 2, it becomes 16 minus 15i, which is imaginary. So these values don't have any pre-image, right? If they don't have pre-image, that means this function is not onto. So you see, just by changing this mapping, the function which was onto earlier gets not non-onto. So the surjectivity also changes. So one should pay utmost attention to where the function is mapping from. All right. So this is the most important portion, where one should pay attention, where the function is getting mapped. Inverse trigonometry. So the first question is, we need to find the value of sine of 2 sine inverse 3 by 5. Now we know that sine inverse gives us the angular value, so we can assume it to be a theta. Let theta equal to sine inverse 3 by 5. So this expression becomes sine of 2 theta. We can use identity 2 sine theta cos theta. Now in place of theta we can write sine inverse 3 by 5, and here as well. Now sine inverse sine gets cancelled, you are left with 2 into 3 by 5, and then we need to convert sine inverse into cos inverse, then only these two will get cancelled. Now we draw a right angle triangle where theta is here, and sine theta will be 3 by 5, because theta equal to sine inverse 3 by 5, then sine theta will be 3 by 5, so cos theta will be 4 by 5. So theta can be written as cos inverse 4 by 5. So we'll put this value, put sine inverse 3 by 5 equal to cos inverse 4 by 5. These two gets cancelled. You have 4 by 5, and if you solve, you get 24 by 25. So that's how you solve such kinds of problem. Now there is another problem which asks you to plot cos inverse x. So we need to plot this function in this range, like for this domain value. So you see, we make value table. So when x equal to minus 1, naturally fx or cos inverse x will be pi. When x equal to 0, x cos inverse is pi by 2. When x is minus half, the value of uh, cos inverse will be 2 pi by 3. So I put this value minus 1, pi, minus half, 2 pi by 3, and 0 pi by 2. And the curve that we obtain is this. So this is the curve we get. So these are two important questions which may turn up in inverse trigonometric problem, like from inverse trigonometric chapter. We'll take on this important questions which may turn up in your board exam. It asks us to prove this relation given A is this. So we normally proceed as usual. We'll take left hand side, and then we'll try to prove left hand side equal to right hand side. So left hand side is 1001 minus plus 0 minus tan alpha by 2, tan alpha by 2 is 1 minus tan alpha by 2, tan alpha by 2. So this is our left hand side. Now we proceed to right hand side. Right hand side will be 1001 minus a is 1 minus tan alpha by 2, tan alpha by 2 1, and then we have multiplied by cos alpha minus sin alpha, cos alpha. So this gives us I minus a, so it will be 1 minus minus will become plus, so it will be tan alpha by 2, it will be minus tan alpha by 2, and then 1. It will get multiplied to cos alpha minus sin alpha and cos alpha. Now we'll multiply it, and then we will get cos alpha row will get multiplied to column plus sin alpha into tan alpha by 2, then minus sin alpha plus cos alpha into tan alpha by 2, and then minus cos alpha into tan alpha by 2 plus sin alpha, and then sin alpha tan alpha by 2 plus cos alpha. So that's what we are going to get after simplifying this expression. Yes. So yeah. All right, now we'll use identity sin alpha equal to 2 sin alpha by 2 cos alpha by 2. So if we use this expression, we get cos alpha into 2 sin alpha by 2 cos alpha by 2 sin alpha by 2 cos alpha by 2, and here we have minus sin alpha plus cos alpha into tan we want tan, right? So tan, I should keep tan as it is, tan alpha by 2 minus cos alpha and alpha by 2 sin alpha, and here 2 sin alpha by 2 cos alpha by 2 sin alpha by 2 cos alpha by 2 plus cos alpha. So we clearly see that cos alpha gets cancelled, cos alpha by 2 cos alpha by 2 gets cancelled. We are left with cos alpha plus 2 sin square alpha by 2 here. So we take on this term and we want to make it minus tan alpha by 2. So I'll separately solve this term here. So minus 2 cos alpha by 2, we have sin alpha minus sin alpha, so I'll write it as minus 2 cos alpha by 2 sin alpha by 2, and then this term is cos alpha, and then I'll turn tan alpha by 2 as sin alpha 2 by cos alpha 2. Now if you take sin alpha by 2 common, you get minus sin alpha by 2 common, you get minus becomes plus 2 cos alpha by 2 minus cos alpha by 2 by cos alpha by 2. When you take LCM, this becomes 2 cos square alpha by 2 minus cos alpha. Now cos alpha will use identity, 2 cos square alpha by 2 minus 1. Now this cos square alpha by 2 cos square alpha by 2 gets cancelled. This minus becomes plus. So this is plus 1 divided by cos alpha by 2. Now this sin alpha by 2 by cos alpha by 2 becomes minus tan alpha by 2. So we can write here minus tan alpha by 2. Similarly, these two expressions are similar. Here, see, these two expressions are exactly similar with extra negative sign. So if you take negative common, it will become minus sin alpha by 2, If you take negative common, it becomes the same term. So here, using this formulation, this simplification, you get tan alpha by 2. Now we'll use half angle formula again here, cos square. So it is 1 minus 2 sine square alpha by 2, 2 sine square alpha by 2. We have minus tan alpha by 2, tan alpha by 2, 2 sine square alpha by 2, plus 1 minus 2 sine square alpha by 2. So this gets cancelled, and we are left with 1 minus tan alpha by 2, tan alpha by 2, 1. So you see, from equation 1 and 2, we can say left hand side is equal to right hand side, hence short. So it is one of the important questions you have. It may turn up in your board exam. So one of the important question from matrices is find x if this is the case. So how to approach for such question? You see, the order of this matrix is 2 by 3, and the order is 2 by 3 again. So we need to find order of matrix X, so that this matrix also gives the same order, So X should be uh, 2 by 2, because then 2 by 2 will get multiplied, and the resultant matrix will be 2 by 3. So let us choose X to be A, B, C, D. So we will multiply A, B, C, D with 1, 2, 3, 4, 5, 6, and that will be equal to minus 7, minus 8, minus 9, and then 2, 4, 6. Now let us find out left hand side. So it becomes A plus 4B, 2A plus 5B, 3A plus 6B, and then C plus 4D, 2C plus 5D, 3C plus 6D, and that is equal to minus 7, minus 8, minus 9, 2, 4, 6. Now we compare these two equations. So A plus 4B is equal to minus 7, and then we have 2A plus 5B is equal to minus 8. Now we can solve these two equations. So if you solve, you multiply it by 2, so it becomes 2A plus 8B equal to minus 14, and this is 2A plus 5B is equal to minus 8. You just subtract. So 3B is equal to minus 6, so B is equal to minus 2. Now you put this B equal to minus 2 in equation 1. So put 3 in 1. So A plus minus 8 becomes minus 7. So A equal to 1. Now we got A and B. Now we need to solve C and D. So we'll take this and this value. C plus 4D is equal to 2, and 2C plus 5D is equal to 4. So we multiply it by, let it be equation 5, this be 6. So multiplied by 2 and by 1, we get 2C plus 8D is equal to 4, and here 2C plus 5D is equal to 4. If you subtract, this gets cancelled. 3D is equal to 0, then D is equal to 0. Put 7 in 1. So we have C plus 4 into 0 is equal to 2. That means C is equal to 2. So the values are A equal to 1, B is equal to minus 2, C is equal to 2, D is equal to 0. So the matrix X turns out to be 1, minus 2, 2, 0. So this is a required matrix. The critical point here is to determine the order of matrix X. So we need to use this concept that when a matrix 2 by 2 and 2 by 3 gets multiplied, this number of columns of first matrix should be equal to number of rows of the second matrix. So the required order of the matrix X was 2 by 2. So that's how one finds like solution to such question. So another important question which can be asked in your exam is by using properties of determinants, solve the equation. So the equation is an inverse of variables x and y and z. So to what we need to take, so we take 1 by x is equal to u, 1 by y is equal to v, and 1 by z is equal to w. Now the pair of equation becomes 2u 3v plus 10w is equal to 4, and then 4u plus 6v plus 5w is equal to 1, and then 6u 9v minus 20w is equal to 2. Now these pair of equations can be changed into matrix form, so we can write it as 2 3 10 4 6 5 6 9 minus 20 into UVW is equal to 4 1 2. Now this can again be expressed as A into B is equal to A into X is equal to B. So what will be A? What will be X? X will be A inverse B. So all we need to do for this type of problem is to find A inverse. Now what are steps to find A inverse? We first have to find minors, then cofactors, and then adjoint, and then inverse. So let us very quickly find out A inverse. We have A is equal to 2 3 10 4 6 5 6 9 minus 20. So minor for first element m11. So how to find minor? If you are finding minor for the first term, just ignore its rows and columns. So if you ignore its rows and columns, we are left with 6 5 9 and minus 20. So m11 will be 6 5 9 minus 20. So you multiply this, subtract by this, minus 120 minus 45, so minus 165. Similarly, if you find m12, it will be minus 80 minus 30 minus 110. m13, if you have values, please tell values. 0. Yes, 0. m21 minus 40. No, minus 60. Minus 60 minus 90 minus 150, right? m22 minus 40 minus 60 minus 100. m23 minus 18 18 minus 18 0. m31 15 minus 60 minus 45. m32 10 minus 30. m33 12 minus 0. 12 minus 0. Now we know cofactors Aij is equal to minus 1 to the power I plus j mij. Now you are right. First of all, while solving this problem, the first step you should be doing is finding out determinant. Because if determinant is 0, we should not proceed with finding minors and cofactors. The determinant of A here will be 2 3 10 4 6 5 6 9 minus 20. So its value will be 2 into minus 110 minus 3 into 0 plus 10 into minus 150, right? So it turns out to be minus 165. 2 into minus 165. Right, minus 165. The first one is this, right? And then minus into 110, and then this one will be 0, right? So it will be how much? minus
10, 3, so minus 100 10 minus 100 zero आ रही value
ये
हाँ minus सर वहाँ 3 होगा 330 होगा हाँ वो 330 वो 330 हो जाता है मतलब टोटल वैल्यू 0 आ रही हो जाएगी तो सर इनवर्स तो एग्जिस्ट नहीं करता
ये क्या है?
इजी क्वेश्चन सर
For this type of questions where the variables are in inverse, we should take 1 by x equal to u, 1 by y equal to v, 1 by z equal to w. The equation now gets transformed to this, and we can write this question in the matrix form like this. Now, first step is to find the determinant of the matrix. Now, if you find the determinant, it will be 2 into 75 minus 3 into minus 110 and then 10 into 72. So if you add these up, it becomes 330 minus 720. So it becomes 0, 8 minus 720. So it will be 0, 4, 240 minus 240. Now, since we say determinant of A is not equal to 0, A inverse exists. Plus, so how much? You'll get 0, 1200. 1200, right? So there was mistake. I took negative here, but it should be positive. Now see, since A inverse, since determinant is not equal to 0, A inverse exists. So this is equation number 4. Now we find minors. So these are minors. What are cofactors? Cofactors is just this formula. So we need to choose negative of the elements that are for these diamond position. So cofactor A11 will be same as minor, it will be 75. A12 will be just negative of this, and A13 will be 72, and A21 will be plus 150. A22 sign won't change. It will remain same. A23 because this is negative. Oh, it doesn't matter because it is 0. A31 will be 75. A32 will be 30. A33 will be minus 24. All right. Therefore, our adjoint of A will be matrix of cofactors and its transpose. So it will be A11, A12, A13, A21, A22, A23, A31, A32, A33. So our adjoint of A becomes 75, 110, 72, 150 minus 100, 0, 75, 30 minus 24. Now A inverse is 1 by determinant of A into adjoint of A. So it turns out to be 1 by 1200 into 75, 150, 75, 110, 110. One is, it looks like 150, right? A21 is 150. 150 minus 100, 0, 72, 0 minus 24. There are two zeros, right? Why we are getting 0 here? That is 30, no?
yeah
Now this is our A inverse. So what will be X? X will be A inverse into B. So A inverse is 1 by 1200 and 75, 150, 75, 150 minus 100, 30, 72, 0 minus 24 into your B matrix is 4, 412. Hmm? So adjoint is calculated or solved is found by taking transpose of the matrix of cofactors. So if you take transpose, matrix of cofactor becomes A11, A12, A13, A21, A22, A23, A31, A32, A33. Now we put these values, so our matrix becomes like this, and then A inverse will, for finding A inverse, we need to divide by determinant of A. Now I said, why if A inverse is determinant of A is 0, we won't find A inverse, because we need to divide it by a determinant of A. And if it is 0, 0 in the denominator will give you something undefined. That is why A inverse don't exists. So we find A inverse only if determinant of A is not 0. So we divide it by 1200 and then we find out x equal to A inverse B as per this equation. So if you multiply, we get A inverse B as 1 by 2, 1 by 3, 1 by 4. So U becomes 1 by 2, which is 1 by x, V becomes 1 by 3, which is 1 by y, and W becomes 1 by z, which is 1 by 4. So x, y, z comes out to be 2, 3 and 4. So that's how you solve. Not only that, you should put these values back to your equation here and verify whether your answers are correct or not. So x2 gives you 1 by 2 by 2 1, y3 gives you 3 by 3 1, and then z5 gives you 10 by 2, 10 by 5 2. So 1 plus 1 plus 2 4. So you can verify all the equations and then be satisfied that your answer is correct. So this question was one of the very important question. Hey guys, welcome back to the Raptors. We are continuing with important questions that may turn up tomorrow. So another important question which has been handpicked is a question related to continuity. So this question says, find the value of k for which the function k fx is given by this equation, like this is value of fx. So k cos x by pi minus 2x if fx not equal to pi by 2, and 3 when if x is equal to pi by 2. We have to find the value of k for which the function is continuous at pi by 2. So for continuity, left hand limit at x equal to pi by 2 must equal to right hand limit at x equal to pi by 2 and value of function at f equal to pi by 2. Since it is given the function is continuous, we can either find out left hand limit or right hand limit, and value of function at pi by 2 is already 3, which is 3. So we need to find limit left hand or right hand for this function and equate it to 3, because value of function at pi by 2 is 3, to find the value of k. So let us find out. Let us find out right hand limit. So right hand limit is limit h tends to 0 f of pi by 2 plus h. So this becomes limit h tends to 0 k cos pi by 2 plus h divided by pi minus 2x. In place of x, we write pi by 2 plus h. So this becomes limit h tends to 0. Cos pi by 2 plus h goes to the second quadrant, and in second quadrant cos is negative. So it will be minus sin h, and this gives you pi minus 2h. So pi gets cancelled. We have 1 by 2 limit h tends to 0 sin h by h. Now sin h by h is 1, so left hand limit or right hand limit gives you k by 2. Now this k by 2 should equal to 3, so k should be 6. So we find after like imposing continuity at pi by 2, the value of k should be 6. These are few important differentiation questions which may turn up tomorrow in your exam. So you see, for solving first, y equal to cos inverse 1 minus x square by 1 plus x square, we take x equal to tan theta. Therefore theta will be tan inverse x. Now, therefore, y becomes cos inverse 1 minus tan square theta by 1 plus tan square theta. This becomes cos inverse cos 2 theta. So it gives you just 2 theta. That is 2 tan inverse x. Now, if you differentiate with respect to x, this gets you dy by dx is equal to 2 by 1 plus x square. So that's the answer. So you could have differentiated it using cos inverse formula as well, but that will take you very long, and there are chances to make mistake. So if you do substitution, it gets easier. Now we come to the second question: y to the power x plus x to the power y, x to the power x equal to a to the power b. Now this is in revision classes, like in last video, I showed you if you have a variable over a variable, one should be using logarithmic differentiation. Now in this case, we take y to the power x is equal to u, x to the power y equal to v, and x to the power x equal to w. Now we take log u becomes x log y, log v becomes y log x, and log w becomes x log x. That implies that du by dx by dv by dx plus dw by dx is equal to 0. So from this equation, because if you take u v w, then you have u plus v plus w equal to a to the power b, which is constant. If you differentiate, you get this. Now, since these are in logarithmic form, we can differentiate it. So, differentiating equation, it will be 1, 2, 3, 4. So, differentiating equation 1 with respect to x, we get 1 by u du by dx equal to x by y plus log y. So du by dx becomes, you cross multiply u. What is u? U is y to the power x. So y to the power x, x by y plus log y. Similarly, differentiating equation 2 with respect to x, one gets 1 by v dv by dx is equal to y by x plus log x dy by dx. So dv by dx becomes v will get multiplied. What is v? X to the power y by x plus dy by dx log x. Now similarly, differentiating equation 3 with respect to x, one gets 1 by w dw by dx is equal to log x plus 1. So dw by dx will be, you multiply log w or just w, you cross multiply w, so that is x to the power x, and you get 1 by log x. So we have du by dx, dv by dx, and dw by dx. So we'll put 5, 6, 7 in 4, and we get 7 in 4, we get y to the power x minus 1 into x, y to the power x log y, plus, if you multiply, x will get cancelled, you have x to the power y minus 1 into y plus x to the power y log x into dy by dx plus x to the power x to the power x log x equal to 0. Now from here we take out dy by dx common, so dy by dx is here, and oh, we should be getting dy by dx here as well, because we are differentiating log y. So dy by dx into dy by dx. So we take dy by dx common. If we take dy by dx common, so we have y to the power x minus 1 plus this term, x to the power y log x, and the rest of the term goes to the right hand side, that is y to the power x log y, x to the power y minus 1 y plus x to the power x plus x to the power x log x. So dy by dx will be, this term will get divided. Therefore dy by dx will be negative of y to the power x log y, x to the power y minus 1 y plus x to the power x plus x to the power x log x, whole divided by y to the power x minus 1 x to the power y log x. That's our answer. The third problem, x is equal to this. So what we need to do, we need to differentiate x with respect to t. So we need to find dx by dt and then dy by dt. So dy by dx will be dy by dt divided by dx by dt. So we need to use UV rule and differentiate x with respect to t, y with respect to t to get dy by dt. So this question is straightforward but quite important. So you should try to solve this question that way. Come to very important question. This may come up in exam. So you see, these two like equations x and y, they depend on parameter t. We need to find d2y by dx square. Let's see how to find out. So we'll differentiate x with respect to t, we differentiate y with respect to t, and we'll find dy by dx by chain rule. So differentiating x with respect to t, so dx by dt will be a. If you differentiate cos, we'll get minus sin t, and then you'll will have to use UV rule here, sin t plus t cos t, and then differentiating y with respect to t, we get dy by dt is equal to a cos t minus it will be UV rule again, so t sin t, and then minus cos t. So dy by dx will be dy by dt divided by dx by dt. So you divide this, minus sin t plus sin t plus t cos t whole divided by a cos t plus t sin t minus cos t. So a gets cancelled and we have dy by dx. Now to find d2y by dx, we need to differentiate it with respect to x. So differentiating with respect to x, again we get d2y by dx square, which will give you ddx of this cos t gets cancelled, sin t gets cancelled, so we are left with t cos t divided by t sin t, t gets cancelled, so we get cot t. So we need to differentiate cot t. Cot t will be minus cosec square t dt by dx. See, we already have dx by dt, so dt by dx will just be inverse of it, so it will be minus cosec square t whole divided by this expression. So it will be minus sin t plus, so this gets cancelled. You already have t cos t. So it is 1 by a 1 by at cosec minus cosec square t sec t. So that is your d2y by dx square. So this question is very important because after you find dy by dx, the parameter still, the dy by dx still depends upon t. So you need to differentiate it again with respect to x, and you have to replace dt by dx by putting inverse of dx by dt. So that is why this question becomes slightly important. So this question talks about a ladder which is inclined along a wall. This ladder is 5 meter long and it is being pulled at a speed of 2 meter per second. So let this be x-axis and this be y. So dx by dt becomes 2 meter per second. Now we need to find out how fast the height of the wall ladder of the ladder changing. As the ladder is being pulled out, it is also sliding down the wall. That means its height is decreasing. So we need to find out how fast the height changing of this ladder. So let this be y, and so using Pythagoras theorem, y square plus x square equal to 5 square. So y square becomes 5 square minus x square. So y will be square root of 25 minus x square. We need to find out dy by dt. So differentiating with respect to t, dy by dt is 1 by 2 root 25 minus x square, and then we differentiate this, we get 0 minus 2x and then dx by dt. So it is minus 2x, dx by dt is 2 meter per second, and then we have 225 minus x square. This 2 gets cancelled. We need to find out dy by dt when x is 4. So put x equal to 4, so 4 into 2 divided by square root of 25 minus 16. 25 minus 16 gives you 9, that is 3, so it is minus 8 by 3 meter per second. So the rate of decrease in height of the ladder is 8 by 3. This suggests that the height of the ladder is decreasing. The negative sign shows that height of the ladder is decreasing along the wall. The length of the ladder will remain fixed, but the height till which the ladder is reaching on wall is decreasing as it is sliding down the plane. Question is about an open box. So it says an open box is to be constructed by removing equal squares from each corner of a 3 by 8 meter square sheet. So this is 3 meter sheet, 3 meter breadth and 8 meter length. What we have to do here, we need to remove equal squares from 4 corners, and after these equal squares are removed, it will be folded up and then an open box will be made. Now this, let the side of the square be x that is being cut from the corners. Now this will be the height of the box. The new length of the box will be 8 minus 2x because x is getting removed, and the new breadth will be 3 minus 2x. Therefore volume will be 8 minus 2x, 3 minus 2x into x. Now differentiating it with respect to x, we should first multiply it. So we get, let us simplify this expression first. So v becomes 24 minus 16x minus 6x plus 4x square into x. So it becomes 24 minus 16 into 22x plus 4x square. We multiply x, it becomes x cube square and x. This is v. Now we differentiate it with respect to x. We get dv by dx is equal to 24 minus 44x plus 12x square. Now for maxima or minima, so this is our expression for maxima or minima, dv by dx will be 0. So 24 minus 44x plus 12x square should be 0. That means you take 4 common, 3x square minus 11x plus 6 equal to 0. That shows 3x square, so we need 18 minus 9x minus 2x plus 6 equal to 0. Now we take 3x common, so x minus 3, x minus 3, you take x minus 3 common, you get 3x minus 2 equal to 0. Now product of two terms are 0, that means either 3x minus 2 equal to 0 or x minus 3 equal to 0. So it will be x equal to 2 by 3, in this case x equal to 3. So we reject this. Why it is rejected? Because the breadth of the sheet is 3. You cannot take off 233 meters squares from this breadth. So the x will be 2 by 3. Now we'll differentiate equation 3 again, equation 2 again, to check whether x at x equal to 2 by 3 we get maximum volume. So let this be 3. Now we differentiate equation 2 with respect to x. We get d2v by dx square, and it will be 0 minus 44 plus 24x. Now if you put 2 by 3, it becomes 44 plus 24 into 2 by 3, it becomes 8. So minus 20, which is less than 0, that means at x equal to 2 by 3 volume is maximum. So the required length of the square that should be cut off is, required side of square is 2 by 3 meters for the volume to be maximum. So in maximum minima problem, what we need to do, we need to formalize the parameter that is needed to be maximized or minimized, and then we differentiate that with respect to x or with respect to the parameter that is that has been asked, and for maxima or minima we equate that to 0. From that equation we get the values of the parameter, and then we check by doing double derivative test whether the required parameter is attaining maxima or minima and at those values of variable or not. So after doing that, we find if the double derivative is less than 0, we get maximum. If it is greater than 0, we get minimum. So here we are getting minus 28, which is less than 0 at x equal to 2 by 3. So the maximum volume is attained at x equal to 2 by 3. So that is the required answer. If we go to integration, there are few integral problems which are tricky and may come in exam. The first one is integration of x 1 by x plus log x. So what we need to do, we need to take x common, 1 plus log x dx. Now we take 1 plus log x equal to t, so 1 by x dx becomes dt. So your I becomes dt by t, and it will be log t plus c. So what is log t? Log t is log of 1 plus log x plus c, where c is a constant. So that's how one should be solving it. Now the next question, which we should solve, is this. Here we take root x common, so it becomes root x minus 1 dx. We take root x minus 1 equal to t, so 1 by 2 root x dx becomes dt, so dx by root x equal to 2 dt. Therefore I becomes 2 dt by t, and that becomes log of t plus c. So 2 log of root x minus 1 plus c, where c is a constant. Now the third problem will be integration of e to the power 2x minus 1 by e to the power 2x plus 1 dx. Now here we need to divide numerator and denominator by e to the power x. Divide numerator and denominator by e to the power x, then it becomes, then I will become e to the power x, e to the power minus x, e to the power x plus e to the power minus x dx. Now we'll take the denominator equal to t, so it becomes e to the power x dx equal to dt. Therefore I becomes dt by t, which will be log t plus c. So this is log of e to the power x minus e to the power minus x plus c, where c is a constant. So these were few questions. We move to the next set of questions now. This integral is very important. 1 by 1 plus tan x. How to solve it? It will be 1 by 1 plus sin x by cos x. If we take LCM, it will become cos x by sin x plus cos x dx. Now we'll have to do some trick. Divide by 2, multiply by 2, sin x plus cos x dx. Now this cos 2 cos x can be written as cos x plus cos x, and then I add sin x, I subtract sin x. I'm allowed to add and subtract sin x. The overall sin x cos x, so overall sum will be 0. So it will be sin x plus cos x dx 1 by 2. So what we did, I wrote 2 cos x as cos x plus cos x, and then I added sin x and I subtracted sin x. That their sum will be 0. Now we will write it as cos x plus sin x, and then cos x plus sin x, and then cos x minus sin x divided by sin x plus cos x dx. Now I'll split this by that and this by that. So it will be cos x plus sin x whole divided by cos x plus sin x dx, then half of cos x minus sin x whole divided by sin x plus cos x dx. Now it will get cancelled, we'll be left with dx, and then half of, if you take sin x plus cos x equal to t, it will be cos x minus sin x dx equal to dt. So this portion will become dt. So it will be dt by t. So it becomes 1 by 2x plus 1 by 2 log t plus c. So x by 2 plus half of log t. What is t? It will be sin x plus cos x plus c, where c is a constant. So this was one of the important question. It is slightly tricky because you need to multiply by 2 and divide by 2, and then you need to add sin x and cos x. The similar a similar type of question can be, can be asked as 1 by 1 plus cot x. So this question will also be solved like that. The next integration is tan to the power 4x. It is also important, very important. So we write it as tan square x and tan square x. That can be further split into tan square x into secant square x minus 1. Then we'll multiply it tan square x secant square x dx minus tan square x dx. Here we are going to take tan x equal to t, then secant square x dx becomes dt. So this integral becomes t square dt. Here we let tan square as secant square x minus 1 dx. So this becomes t cube by 3 minus secant square is integration of secant square is tan x and x plus c. So t is tan t, tan x, tan cube x by 3 minus tan x plus c, where c is a constant. Integration 1 minus cos x by 1 plus cos x is extremely important. Here we need to use half angle formula. So 1 minus cos x becomes sine square x by 2, and then 1 plus cos x becomes 2 cos square x by 2. 2 gets cancelled and we are left with tan square x by 2 dx. Now tan square is very straightforward, secant square x by 2 minus 1 dx. So integration of secant square will become tan x by 2 into 2 minus x plus c, where c is a constant. So we need to use half angle formula here to solve this integral. Now we go to application of integrals. Not application of integrals, definite integrals. We are going to definite integrals. In definite integrals, we get three types of problem. One is modulus problem, other is of limit minus a to a, and then third is rest. In modulus problem, we should split the limit. In minus a to a, we need to check odd eve function. And here we should use f of upper limit plus lower limit minus x. The integrand will be upper limit, lower limit minus a. Now we'll test one integration one after another. So let us take a question. Here I is x cube minus x dx. The limit is minus 1 to 2. Now you see this is modulus function. Now since it is a modulus function, we need to find critical points. What are critical points? Where the function is 0. So x square minus 1 equal to 0, that means x plus 1, x minus 1 equal to 0, that means x equal to 0, x equal to 1, x equal to minus 1. So we are getting three critical points, 0, 1 and minus 1. So we have 0, minus 1, 1, 2. We have to integrate from minus 1 to 2. Critical points are this, 0 and 1. Now we will find out where the function is positive and where the function is negative. So this is real line. We choose any number beyond 1. So if you choose beyond 1, something 2 cube, and this is positive. So here we have positive. Suppose we choose 2 or 1.5 cube minus, suppose we choose 2, so 8 minus 2 is 6 is positive. So this range is positive, automatically this negative, positive, negative. So positive, negative, positive. Now, when We know the modulus function. The definition of modulus function is minus x if x is less than 0, plus x if x is greater than equal to 0. So where the function, the modulus function is positive, we take just the positive value of the integrand, and if it is negative, we choose negative. So your I becomes minus 1 to 0. The integrand is positive, so we'll take just x cube minus x dx. And then from 0 to 1, since it is negative, we'll take negative. So we choose negative here, and then we take positive. So 1 to 2, x cube minus x dx. Now, the integration is straightforward. X power 4 minus x squared by 2, and 1 to 0. X power 4 by 4 minus x squared by 2, 0 to 1. X to power 4 by 4 minus x squared by 2, 1 to 2. We put upper limit and then lower limit, so 0, 0, minus 1. If you put minus 1, 1 by 4 and then 1 by 2, minus here 1 by 4 minus 1 by 2 minus 0, and then here 2 to the power 4 is 16, 16 by 4 is 4, minus 2 square by 4, 2, minus 1, if you put 1, 1 by 4 minus 1 by 2. So after solving this, we get minus 1 by 4, minus 1 is plus, we get 1 by 4, so plus 1 by 4, minus 1 by 4, and then plus 2, minus plus 1 by 4. So this gets cancelled, we get 9 by 4 square units. Since we are finding out not square units, it is just an integral, so it will be 9 by 4. So the thing that we need to keep in mind is whenever we come across this modulus function, we'll have to use the properties of modulus function where we need to split the range, split the integration range. So if the integrand is positive, we leave the integrand as it is, and if it is negative, we leave it. We just put a negative sign with the integrand. That's it. So it is extremely important, and I think one modulus problem will definitely turn up in your exam tomorrow. Now here we see the limits are minus pi by 2 to pi by 2. So we need to check the odd or evenness of this function. So we have sine to the power 7x, and you know if x is negative, it becomes if it is fx, then f of minus x will become sine of minus x to the power 7 will be minus sine power 7x, which is minus of fx. So if it is minus of fx, it is an odd function, and in this case, if the function is odd, it will be 0. So you can directly write since fx is odd, or you can write since sine to the power 7x is odd. Next integration is see in this integral. This is definite integral in your syllabus. If it don't has modulus, if it don't has minus a to a limit, then the third possible kind of property that you need to use is we replace the function fx dx a to b is equal to f of a plus b minus x dx a to b. So this can be 0 to pi minus x sine of pi minus x, let it be equation 1, 1 plus cos square pi minus x. So it becomes 0 to pi minus x Sin pi minus x will be sin x, and then 1 plus cos pi minus will be negative of cos x, but then it will be cos square x dx. Now we can multiply it, like we can multiply sin x to pi and then x, so it will become pi 0 to pi sin x by 1 plus cos square x dx, and then minus of 0 to pi x sin x by 1 plus cos square x. Now you see, this is exactly what we had in the problem. So it is minus I. So I equal to, therefore I equal to pi 0 to pi sin x 1 plus cos square x dx minus I. We'll take this I to the left hand side, that will become 2I. Therefore 2I equal to pi. Here we take cos x equal to t, therefore minus sin x dx becomes dt. So sin x will become minus of dt. So when x is 0, t is 1. When x is pi, t is minus 1. So we put 0 here in cos x. So when x is 0, t becomes 1. When you put x equal to pi, t becomes minus 1. So your this 2I becomes 1 to minus 1. And then sin x dx becomes minus dt by 1 plus t square. So 1 by 1 plus t square will give you tan inverse t. So 2I is pi tan inverse t, and then it will be 1 to minus 1. That will be pi tan inverse of minus 1 minus tan inverse of 1. So tan inverse of minus 1 will be minus pi by 4, it is pi by 4. So it becomes pi into minus pi by 2, so it is pi square by 2. And that is 2I. And therefore I will be minus pi square by 4. So that is your answer. So that's how one solves a problem which is neither modulus nor minus a to a type. So we use the third property, the latest property that is mentioned here, that you need to do upper limit plus lower limit minus x. So guys, these were extremely important set of questions which may turn up in your exam tomorrow. To cover the rest of the syllabus, guys, I'm going to make another video and we'll post them soon. So stay tuned, guys. We'll meet in the next video. Till then, take care. Bye.